Oh,
Ready?
yeah.
Hey! Tag! Team, we're back again. What is slope?
Hey, this is one of those words we actually hear every now and then in real life.
Sometimes we do.
Not like those math words. They're like, oh, when am I ever going to actually use the word slope?
Construction workers,
No.
architects, engineers. Here's a few definitions of what slope is.
Would this be a good thing to have them?
Good for the nose. Yeah. Slope is the steepness of a line, how uppy or downy it goes. And a bigger slope means it's steeper. The rate of change.
Comment below if you know what movie this is from. Welcome to the Rock, gentlemen.
Rate of change is a phrase you'll hear in math from now through calculus. The high school math teachers really like to use the ROC for rate of change instead of calling it the slope.
Because it's... Or sometimes you'll hear it referred to as rise over run. The M in y equals mx plus b. Or really fancy people,
Yeah.
they call it delta y over delta x. And the delta means...
It means change. You might have seen that in your science classes.
Yeah.
Speaking of other classes, back in 7th grade when you had a constant ratio, you were looking at a slope.
Yeah. All right.
You ready to show us how to do it, Mr. Sliger?
Absolutely. So, here is our line. Y equals 2/3 m, right, our m, 2/3 x minus 3.
You already graphed it.
It's already there, look at that. Now, we're going to try and find where is that 2/3. My hint is they're in orange. We made them orange,
Yeah, they're already
so you could see them. So, we would start at 3, but then we're going to look here. That's the, is that the rise? Or the, that looks like the
That
rise.
looks like a fall to me.
Or fall. But it's the change in
That's the change
y.
in Y.
Yeah,
It's all
change in
Y.
Y. So this is the
That's the run.
change in x, the change in y, the rise.
Now,
You said
now I
fall.
see the rise.
Yeah. Could it be fall though?
I guess if we wanted to use negative numbers.
Yeah. So the rise and fall, or fall, and this is the run. So you can see it a couple different places, right? So I can see the slope. Here's my 2.
Where's the 2?
Right here's 2. That's the rise.
Rise to.
Or the run is that 3. It runs. Yeah.
What if I did it this way?
Ooh. Does that have the same slope? What's the change in y?
2,
What's the change in x?
3.
3. So that has the same slope.
But what if I did it this way?
No, you can't. Actually, you can. So we would just ask ourselves the same question.
That's not 2.
It's not 2. Wait for it. It's 2, 4, 6, 8, 10. And then the change in
Run.
I bet that's going to be 15.
It is 15.
So
Rise 10. Run 15. That's not 2/3.
it's not
Mr. Sliger.
2/3.
Wait, is it 2/3?
It is 2/3. So
That's good. I like that. You can just count it on the graph.
you can count it. Yeah.
But I got another way on our next slide. Maybe they don't give you a graph.
What?
I've got a table. There's our m again, 1/4. So you already know what the slope is, but can we see it in the table? When I add 1x, I add 1/4 on the y. Add 1x, add 1/4 on the y. Change in y over change in x.
Can I have a fraction on the top of a fraction?
Well,
That's weird.
y over change in x, 1/4 over 1, but divide by 1 is easy.
Oh, yeah.
So it's just 1/4.
But Mr. Al, what if I went down here
Yeah, let's do
and
that.
and I found that this change was
That's 1.
1, so
How
the
much-
change in y is 1.
How much did the x's change?
4, so we got a different slope then, right? Because, oh no,
Because change in y
it's the same. 1,
over,
4.
oh yeah, I can trick you though. What about from 4 to 12?
Let me do that.
You do that.
So,
With the blue.
change in y
Yep,
from 4 to 6, that's 2.
2.
And then the change in x from 4 to 12 is 8. Ooh, that's secret code for 1/4.
It's the same.
Wow.
How'd you get the 8?
That's the difference between 4 and 12.
And how do you calculate difference?
Subtraction.
Subtraction.
There you go.
Because,
So we can do that if we have the graph,
yep,
if we have a table.
any other ways?
I bet there is, because there's more slides.
That there are more slides. If that one will go away. There it is.
There it is.
So the hardest they might look like is this one. Could we turn that into a table and do what we did on the last slide? Could you graph them and count the slope on the graph? We could. But there are other ways, which we have our 3 quick questions to ask. What is the rise? How much do the y's change? Which one are the y's?
Second one.
The second ones are the y's because alphabetically we do x's first. I have a lot of students that find it's easier to write the x and the y on the points. But all right, what is the change in y from 4 to 6? What is the run, the change in the x's, from 3 to 4? And so the slope is rise over run is 2 over 1, and I bet you know how to simplify that one. We can just call it 2.
That seems really easy.
It should be.
My question real quick though, Mr. Al, is you said the difference. So the difference between 4 and 6, doesn't that give you -2?
Well, let's do it that way. 4 minus 6 is -2. What's 3 minus 4?
3 minus 4 is -1.
And now the rate of change, the ratio of -2 to -1,
Oh, 2 negatives make a...
make a +2. Works out either way.
Right.
We're so close. Just for your notes, the slope formula in 3 different ways. Now, if you're writing in your notes,
Which should be.
in the vocabulary section, this is a good place to have. If you're writing in the dots and lines, that's a good place to have. There's also a formula page on the back you might never have noticed with a place for your formulas. Slope is rise over run. That's the shorthand that a lot of people learn in school. It's not very mathy,
I've heard that a lot.
but it's easy to remember. The science way to write it, delta y over delta x, or change in y over change in x. Why did they pick the letter M? I did a research project on this in college. All the other letters were taken. They already used S for slope and R for rate of change, so they used M. And the most mathy version of this, which looks kind of scary,
But we just saw...
we just saw,
Not that bad.
not that bad, the y number 1 minus the y number 2. That's what Mr. Sliger did. He subtracted the y's, then he subtracted the x's. That's all the little 1 and 2 mean. They're not exponents. You don't multiply by 2 or anything like that. It's just first y,
Labels
second
to
y.
help keep straight.
Yep, first x, second x, and that's the formula. But we do have a bonus slide. Some funky special cases. You might get caught off guard if you run into these. A horizontal line, rise 0, run anything. 0 divided by anything,
0.
Zero slope. But that's different than a vertical line. Rise anything, it doesn't
Doesn't run.
run. What's its slope? What's its m value? It doesn't have one. The answer to what is the slope is no. There is no slope.
No is different than 0.
Nope.
This is 0, this is no slope.
There's a difference between having $0 in the bank and not even having a bank account.
Yeah, there's just no bank. Like, I went to there wasn't a bank.
How steep is this road?
No.
Zero steep. How steep is this road? That's not a road, that's a wall. There we go.
Hey, good luck.